What's the legacy of Francis Galton's work? I mentioned before his contribution to fingerprint analysis, his contribution to behavioral genetics with the method of twins, his contributions to expertise research, to psychometrics. Here I want to concentrate in two methodological approaches and in one statistical method. His focus on measurement of large samples is possibly the most important methodological approach that Galton leaves us. After that, measurements in large samples was used in psychology and is used has been used since then. Another important legacy is the study of individual differences, how people differ. So this study, which is the differential psychology, is not mainstream now, but we tend to forget the importance. Probably in the area of expertise, my area of research, or one of my areas of research, we take this study of individual differences into account. Perhaps in a different way, perhaps comparing different groups. But the idea is to use whatever methodology to know how people differ, know how people are the same. Finally, the concept of regression to the mean. I mentioned when I explained the quincunx that Galton discovered when measuring parents and offsprings that the distribution of traits like height does not change, doesn't get more extreme as the first of the quincunx suggests. What he realized is that the height, the distribution of height in parents is the same as the distribution of height in offspring. So how does that happen? And what he found is that if you plot the height of parents and the height of children in a graph, then what you'll see is what is called a regression to the mean. He called it reversion at the beginning because he tried to provide an explanation to that, an explanation related to some process, to some biological process, to some evolutionary or a process of inheritance. But he didn't find anything. So he then realized that that was a mistake, and he changed to the concept of regression rather than to reversion. The idea is that parents that are very, very tall, that are in the top of the tallest parents, their offspring tend to be shorter. Yes, they tend to be shorter. Why? Because they are sort of reaching a limit for the species in terms of height. So more than that is difficult for the organism to be able to achieve. And if you think that that height has to do with inheritance, but there are some random components as well. If those random components apply everywhere in the range of possible heights, the top and the bottom of the distribution, their randomness can only go one way. For example, if you are reaching the highest possible height that your species accepts, so to speak, then you can only have a random fluctuation that takes you to a lower height. Same with the shortest people. Their offspring, by chance, they cannot become shorter because they've sort of reached the limit of the species, but their random variation may take them to be a bit higher. That produces the effect of regression to the mean. There was absolutely no biological or genetic component. Why? How did he find out? Well, he found out that because he could predict the height of children based on the height of parents, but he realized he can do exactly the same. There is regression to the mean when you try to predict the height of the parents based on the height of the offspring. But that is a reverse process that doesn't occur in reality, so that cannot explain the phenomenon of regression to the mean. So it was just a statistical artifact, and therefore he changed this concept from reversion to regression to make it neutral, just statistical concept. But at the same time, he abandoned what he was really good at, trying to give causal explanations to events.